Okay, today's November 2nd, 2011. We're doing lesson 5.6. We're going to focus on factors of a perfect square. Or sorry, I said that wrong. We're going to focus on difference of squares. Okay, and then we'll recap how to solve a perfect square using the methods we learned the other day. So an example of a perfect square would be x squared minus 25. Now I'm going to go through the steps here. If you guys remember, we're used to seeing equations where we have ax squared plus bx plus c. So we have an a b, and a c. Now, in this polynomial, or this quadratic expression, this binomial only has two terms. What of our variables a, b, and c, which ones are actually present in our question? A is what value? Okay. And what is the other one that's present? C. Okay. We're looking at a difference of squares. This is very important. Does anyone remember what difference stands for in math? Yes. So, difference of squares. Okay. It's very important that if we're in this two-term form, it has to be subtraction sign in order to do the factoring I'm about to show you. If it's an addition sign, it will not work. Okay? So, in order for this to work, I need it to be a subtraction sign between the two numbers, and I need to be able to find the square root of both terms. So that means I have to be able to square root our first term and our second term. So when I think about it, what would the square root, and we're going to put it into factored form. The square root of our first term will be the first terms in the bracket, and the square root of our second term will be the second terms in our brackets. Okay. What would the square root of x squared be? What is it? X, that's right. The square root of x squared is just x. We know that x times x equals x squared. So my first term in both brackets is just going to be x and x. Now, disregard this negative sign because we can't find the square roots of negative numbers. Square root of 25. What is it? 5. We know that 5 times 5 is 25. So, our second term in each bracket will be 5. Now, here's the only tricky part. I need to put an addition sign in one of the brackets and a subtraction sign in the other. So essentially our answer is x plus 5. I'm just doing it in black. It's the same as before, x minus 5. We're multiplying both by each other. Now we're going to talk about why this works now. Okay? To check, what would we do to check a question like this? Anyone remember? What is it? Expand and simplify. So we can do the rainbow method, we can do FOIL, we can use algebra tiles. I'll quickly do our FOIL method. Okay. I'm going to multiply the first terms. What is x times x? That's right, we're going to end up with x squared. Then I'm going to do the outside terms, x times negative 5, what does that give us? Negative 5x. Then we'll do the inside terms, positive 5 times x, positive 5x. And finally, our last terms, positive 5 times negative 5 is negative 25. You notice the two middle terms are essentially opposites of each other. One is negative 5x, one is positive 5x. They're going to cancel each other out. So we're left with x squared minus 25. So that's the idea behind factoring a difference of squares. We're able to find the square root of the last term. If you guys remember, square root of 25 is going to give me these two terms here. And the square root of our first term will give us our first terms in the brackets. Okay, we're going to do example 1b from page 251. They've asked us to factor this expression. No problem. What is the first type of factoring we look for? We just talked about it. Common factor. We need to find a common factor, or the greatest common factor in that case. Is there a common factor between the variables? Let's look. We have a squared and b squared. Is there a common factor there? No, I can't take anything out. Those are both different variables, means they represent different numbers. I can't factor anything from that. How about 98 and 450? 2. I can take 2 out. So I know I'm going to divide both of these by 2. When I divide it by 2, the 2 goes to the outside. 98 divided by 2 gives us 49a squared minus 225 b squared. Okay. So, again, I'm looking at these terms. I kind of need to figure out if they are squares, if I can square root them. I know there's 2 terms, and I know it's a subtraction sign in between, difference of squares. Okay. So I'm going to test this out. I'm going to go to my calculator. Is there a square root of 49a? Anyone know what it would be off the top of their head? 7 what? Yes. We're square rooting 49a squared, which means I'm going to need 7a. I have to multiply 7a by 7a to get 49a squared. Does that make sense? Okay. So in our factored brackets, we know our first term is going to be 7a. Now for our last term, 225b squared. I need to see if there's a square root of this. Let's bring up a calculator. We know there's a square root of b squared. What will it be? There we go. 225 square root. Perfect. 15. So we figured out that the square root of 225b squared is 15b. That means our second term in the bracket will be 15b. 15b, and I need to put a positive and negative sign, so we know that that middle term will cancel itself out, and this, my friends, is your factored form. Okay, the next type of question we're going to deal with, this is called a perfect square trinomial, okay? And what that means is that we have our trinomial, we have our a times x squared plus bx plus c. We're looking to see if we can find the square roots of the first and last term again. And if they're square roots, essentially multiply by each other times 2 to create the middle term. Now I said a lot there. I'm going to show you what they're talking about. They've written it in this form, okay? They write a squared plus, we'll do that out here too, b squared is our last term, and times 2ab. So in a perfect square trinomial, our first term is a perfect square, hence our a squared. Our last term is a perfect square, hence our b squared. And the middle term, it can be solved by finding the square root of a, the square root of b, and multiplying it by 2. So in other words, a times b times 2. Okay? And if that's the case, we can write it in a special factored form. So they want you to be able to recognize this. I'm going to find the square root of the first term. Square root of x squared is? Yes. Square root of our last term, 9, is? 3. Now, in other words, that's our a and our b. I should have wrote, I'll write this in blue so it makes more sense. Okay. And we got to see if it tests and makes our middle term. So in order to make our middle term, we need to multiply a and b times 2. So I'll do that on the side. We'll do that in green. Okay. 2 times a is x and b is 3. What do I get when I multiply those together? 6x. Is that the middle term? Yes. So by testing this, I know that this is true. I know that the square root of a, which is x, and the square root of b, which is 3, when I take both those numbers and multiply by 2, which is what this says, I end up with 6x, which is this middle term. If that's true, I can factor it like this. Just one bracket. I take the square root of our first term, which we did here, which is x, square root of the last term, which is 3, okay? Put our plus sign in here because it's positive 3, and I just put a squared on the outside of the bracket. Now I know that's a lot to remember. I'm going to show you how we'll get the exact same answer using the factoring style from 5.5. So we're going to do the exact same question. Question said x squared plus 6x plus 9. Okay. Okay, so we'll use our normal factoring method. If you guys remember, here's our a term, b term, c term. Factors of our a are what? 1 and 1, because that number we assume is a 1. Factors 1 are 1 and 1. Factors of our c term are 1 and 9 and 3 and 3. We know that we need to multiply the columns together, and those products got to add up to 6, our b term. They have to add up to our b term, which is 6. Okay, so we have our columns. We're going to be going into a factored form. Okay, we need to multiply. So let's test this out. 1 by 9 and 1 by 1, 1 and 9. Is that going to work? And if I go across anything different, I'll just get 9 and 1. Doesn't work. So we know that this column does not work. 1 times 3 and 1 times 3. Any combination of 3 plus 3 work? If they're both what? They're both positive. So we know that both these terms need to be positive. 3 and 3 works. So we figured them out. These will be our first terms, 1x and 1x. Do I need to write the 1 down? I can just write x. So x and x are our first terms. And our second terms are going to be what? Positive 3 and positive 3. Anything familiar about those brackets? They're the exact same. So instead of writing them out that way, when you have two brackets that are the exact same, I want you to write it like this. Okay, now we'll do the exact same method using decomposition. Sorry, not same method, same factoring, same question. Okay, using decomposition, we have our A term, our C term, and our B term. We know using decomposition we need two numbers that are going to add up to our B term, which is 6. And we also need two numbers that add up to our A term times our C term, which is 1 times 9, which is 9. So we need two numbers that add to 6 and multiply to 9. What are they? 3 and 3. Now technically we would have to go through the factors of 9 to solve this, which are 1 and 9, 3 and 3. Clearly 1 and 9 don't work, so we know it's 3 and 3. So we put 3 and 3 in. So now when we go to decomposition, we're going to get x squared plus 6x plus 9. Remember, I split the middle term into our two new terms, our 3 and 3. So we have x squared plus 3x plus 3x plus 9. Now I group them. I'm going to factor by grouping, find the common factor of each bracket. Common factor of the first bracket is x. When I divide both terms by x, I get x plus 3. Common factor of the second bracket is 3. When I divide each term by 3, I get x plus 3. And if you notice, both the brackets are the same. So we factor that bracket out, and we're left with x plus 3. And then in our other bracket, whatever's left over, plus 3. And both brackets are the same, so how can I represent it? Squared. We just write it as one term, and we put a square on it. So those are the 3 methods. Last one was decomposition.